Today we will be learning about orthographic projection of points. That is, now before proceeding ahead, let's first know what is the actual meaning of it. That is, what do you actually mean by orthographic projection? Points, everyone knows what is a point. Now, when you talk about ortho simply means 90 degree. Anything related with the 90 degree, I will call it as ortho. Say you have got orthogonal diagonals of square and the other things. Graphic is nothing but the graphical representation of something. And then coming to the most decisive word, that is projection. What do we exactly mean by projection? Now when you talk about projection, then in Latin we said the projection is nothing but it is to throw something forward. To throw something forward. Okay, but what is happening in engineering drawing or engineering graphics, that is the students are just simply getting confused between this projection word with the shadows or you say the mirror image. Now if you ask someone, I want a real example of projection, then the students say, okay sir, this is nothing else but you take a ball or you take something or the shadows which are being formed. The contrary question which comes out here is, if my projections are your shadows or say the mirror images, then the question which really arises in my mind is, for a shadow or for a mirror image, we need an object out there. Am I right or not? Now, if that object is not really out there, then how can the shadow be there? Now, this is one part. Now, say you want to make some building. Before making a building, or say you want to make some object, any machinery object you want to make. Now, if the projections are shadows, that means that object has to be there. But if the object is already out there, then what are you trying to make? Is it clear to everyone? So here, there is something faulty out there. There is something wrong. Let's try to check it out. Let's take a very simple example. Not exactly ortho, but yeah, somewhat related to it. That is, I hope every one of you have been to the cinema halls. Agreed? Now when you go to a cinema hall, what do you see? What is there in front of you? It is nothing but a screen. Agreed? And then on the back side you have got a machine. What is that machine called as? Projector. Now what is that projector basically doing? It is simply projecting n number of rays of light. N number of rays of light. Now there is some cellulite film which is coming in between, and whatever is there on that cellulite film that is being depicted on that screen, is that thing really out there? Is that object which is being represented or being depicted on the screen, is it really out there? No, it's not there. Only its representation is there. And something like this is happening in our engineering drawing, or we say engineering graphics also. But the question arises, where is this screen for us, or where is the projector? Now this screen is simply replaced by your reference planes, and there are two basic reference planes. One is the vertical plane, the plane which is perpendicular to the ground, and the other which is horizontal plane, the plane which is parallel to the ground. Let's see it out here. Now this is a plane, vertical plane, also called as VP, which is simply perpendicular to the ground. Another plane, the horizontal plane, which is parallel to the ground. Now as you can see, these two planes are basically intersecting each other exactly at 90 degrees. I hope now you can understand what we mean by ortho. Exactly at 90 degrees. And these planes are totally imaginary and transparent planes. There are lakhs and lakhs of planes between me and you right now. Okay? They are totally imaginary and totally transparent plane. Now, just to take the help, what I will do is, I will take an object. Now, the object right now is going to be my point. Although this object is not there, but just for our support, we take it, a point is there. So, here we have the screen as the vertical plane and the horizontal plane. And now comes the second part, projector. In this case, we are not having the projector, rather we are having an observer who is standing at some distance away from the these totally imaginary and transparent planes. The question which comes in my mind, what is this distance from here to here? Or from this object to this particular point? The answer is very simple. The answer is, the distance is nothing but it is totally infinity. How much is it? It is totally infinity. Why we consider it infinity? And here comes the reason behind it. Because anything which is at infinity, or if there are two parallel lines, if I consider two parallel lines, then these parallel lines are supposed to be meeting at infinity. Let's take a very simple example. Say, you are standing on a railway track. The tracks are totally parallel to each other. But finally when you see it, you see that they are going to merge at one single point. And that is what is happening out here. Similarly, if something is coming from the infinity, we assume it to be coming parallel. For example, you must be drawing some of the lenses or the reflectors in the junior classes where you have taken a lens like this or the reflector is out there. Then the rays which you have shown was simply parallel to each other. Why? Because they were cosmic rays, supposed to be coming from infinity. So anything which is coming from infinity, if the rays are coming from the infinity, then definitely they will be traveling parallel to each other till the time they reach my object. Okay? So, if this observer is there, he is standing at the infinity and observing this object as you are standing out there. Now, if you see me from front, what do you see? This is the front view of me coming. Similarly, the representation of this point, I represented by capital P, is going to be taking place on the vertical plane as P and will be represented by small p dash. Whereas when this observer, he comes on the top and looks from here, then the representation is coming on the horizontal plane and is represented by small p. As I can see clearly, the representation of front is taking on vertical plane. So this plane is also called as front reference plane. Whereas this horizontal plane is also called as horizontal reference plane. Am I clear to everyone? Okay. Now if you see, when these two reference planes, they intersect each other, what you form is four quadrants. There are four quadrants: first, second, third and fourth. Now again there is a big confusion out here. Where is the first one? As you know that if the observer is here, then the first quadrant will be the uppermost right hand side part. This will be my first quadrant, this will be my second quadrant, this will be my third quadrant and this will be my fourth quadrant. Whereas if I go on that side, that is if I am standing on this side, now if the observer is standing on this side, then the right hand part, the uppermost part, this is going to be my first quadrant, this is going to be my second quadrant, this is going to be my third quadrant, and this is going to be my fourth quadrant. Mind it, my dear friends, now the observer will be on the back side of this blackboard. He will no more be on this side. Am I clear? But as such, we will be dealing from this side. So it is first quadrant, second quadrant, third quadrant, and the fourth quadrant. That is, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Now let's try to move this point from first quadrant to say the second quadrant. Here. The point is out here. Now, the obvious question is, where is my observer? In this case, the observer will remain on this side. That is, if you are the observer right now, so will you remain on that side, or will you come on this side to see it? Obviously, many of the students, they say this thing, sir, will come on this side. No, that is not the answer. You will remain on that side only. You will not move on this side. Because if you go try to come on this side, then this is the angle which you are taking. This is totally 180 degree and you are avoiding 90 degree, that is orthographic projection. So my dear friends, for first quadrant, that is you, the observer, will be on this side only, and for first quadrant I can simply say one thing, that the equation goes this way. First quadrant, it is the observer, then comes the object, and then comes the reference plane. I'll show you on the diagram. This is the object. You are the observer who is supposed to be staring at infinity. Observer, object, and the reference plane. When it comes into the second quadrant, then the equation is definitely going to change. But we will not be considering that equation at this moment. Obviously, the observer is out here. So now the representation of this point, mind my words, representation of this point will be done on this vertical plane as P dash. Let me again remind you one thing. Would this having a shadow, an observer as a light or a source of light, then this would have been going backside. Because you can never say this thing, if some shadow is out there or some bulb is out there, and then suddenly what happens is your shadow is coming on the front side. No, it cannot happen. It cannot happen in that way. Am I clear to everyone? Okay. Now, so this is the representation in the second quadrant. Again, for the top view, we'll have it on the horizontal plane coming like this as P. Now the point moves into the third quadrant, that is out here. Say the point is here. This is P dash. Here you have as P. So this is the representation for the front view in third quadrant, representation for the top view in third quadrant, and then comes my fourth quadrant. Obviously, out here, this is my P. Its representation is coming here as, for the front view as P dash, and here it is coming as small p. Am I clear? Now, the drawings are basically being done in two quadrants, that is the first quadrant and the third quadrant. So what should be the equation of the third quadrant? Obviously, you being the observer, you have to be there. Okay? So, you are the observer, reference plane, and then comes the object. Observer, reference plane, and the object. Now many of you must be thinking this thing, sir, how can we see the object? My dear friend, let me again remind you this thing, that these are totally imaginary and transparent planes. totally imaginary and transparent planes. So what should be the equation for the third quadrant? It should be, first will be U, that is observer, then comes the reference plane, and then comes the object. Is it clear? Okay. Now, so we have plotted all the views out there, the front view, the top views and everything. But the question is, everything is in 3 dimension till now. Everything is in 3 dimension. But the drawings are being made in 2 dimension. Where the object, main object is not there, only its representation is there. And here on, we will be talking only about the first quadrant. We will not be dealing with the third quadrant. Okay? Until unless not very much required to explain you the concepts. So, we are talking about the first quadrant. How come the things are coming in 2 dimension? Now, I cannot take this model to give you this thing, okay, this is the front view of some machine part, or this is the front or top view of some machine part. Obviously, we need some sheet to lay down the whole diagram over it. Okay? Now, how to bring it into 2 dimension? Let's see that. For that, what is done is, there are 2 assumptions to be made. That is, one plane is to be kept as constant. The other plane is to be rotated in some direction. Now, if I am keeping my vertical plane as constant, this plane now I am going to keep it as constant. Then I will rotate the horizontal plane, that HP, in clockwise direction. Whereas, if I keep my HP as constant, I will rotate VP in clockwise direction. We will definitely be dealing with this assumption. That is, I will be keeping my vertical plane as constant and rotating the horizontal plane in clockwise direction. In clockwise direction. Now look at my dear friends, as we have decided in the starting that this point P never exists. What is there? Only and only its representations are there. That means I should now remove this point from here. And only its representation is there. That is in the first quadrant. In the second quadrant, in the third quadrant. Now we can say yes, I am having only the representation of the particular point. Later on, these points will turn out to be machine objects, lines, planes and solids and everything. Now I have to bring them in 2 dimensions. Look what happens. This is the plane, that is the vertical plane, on which I am having the front view. This is the horizontal plane on which I am having the top view in the first quadrant. Obviously, now keeping this vertical plane, if I simply resolve this plane in clockwise direction, now clockwise for me, because the observer I am out here, so for me this is the clockwise direction. If the observer is on that side, this would have been the second quadrant. Again, let me remind you that thing. This would have been the first quadrant. Coming to this side again, keeping this as fixed, rotating this in the clockwise direction. What do I see? That front view is coming up, top view is coming down of what? A reference line which is simply dividing the 2 reference planes, the vertical plane and the horizontal plane, called as XY line. Called as XY line. Let's see how it happens. So when we talk about the first quadrant, then This is my XY line. Now let us see the different views in different quadrants. Let's talk about the first quadrant. Then, this is my XY line. And this is how I will be getting the things. Obviously, here I have the front view, here I now have the top view, and this is my XY line. This is how my front view will be above the XY line, whereas the top view will be below the XY line. Let's talk about the second quadrant. What will happen in the second quadrant now? Just see. As I can see, keeping this vertical plane as constant, when I am rotating this HP, as you can see it in this way, when you rotate this HP, it goes and intersects the vertical plane. It goes, now look, you can see it rotating in the clockwise direction, it goes and intersects the vertical plane above XY line. Now till now we have seen then how the different views are coming in different quadrants. That is, in the first quadrant we saw that the front view is coming above XY line, top view is coming below XY line. In second quadrant both of them are getting overlapped above XY line, whereas in third quadrant top view is coming above XY line, front view is going below XY line, whereas in fourth quadrant, both of them are getting overlapped below the XY line. Now the time has come that we should learn about how to get the side views of an object. Now for front view, we were using vertical plane. For the top view, we were using horizontal plane. And for the side views, I will be using a plane called as profile plane. Now what is profile plane? Profile plane is the plane which is perpendicular to both HP and VP. Both perpendicular to both HP and VP. And as we have got two views, one is right hand side view and one is left hand side view, obviously I will be needing two profile planes. So the other profile plane will definitely be coming somewhere here, like this. So now I've got two profile planes, say PP1 and PP2. These two profile planes are now fitted at this point, that is, there is one plane called as profile plane 2, PP2, and one will be here as profile plane 1. One of them has to be used for right hand side view and the other has to be used for the left hand side view. Question is, which one has to be used for which view? So for that, again let's take the help of the point. Say we consider that point again out here. Here we have this as P. Obviously its front view is coming as P dash. The top view is coming out here as P. Say the observer is observing it from his left hand side. This is the observer. Now, on which plane will I be taking my views for the left hand side? This one or that one? PP1 or PP2? Obviously, we are dealing in the very first quadrant. And the equation of the first quadrant, if you remember, again I will write it down out here, is it's observer, object and plane. That means this is the observer, this is the object. That in that case I will be removing this plane and the projections will be coming on this plane. Whereas when you go on that side to see it, that is on your right hand side, so this will be the observer, PP1 will be removed from here and you will be seeing the views on the left hand plane, that is on PP2. Now these two planes are basically hinged with the vertical plane. They are hinged with the vertical plane. That means they have got only two chances. Either they can open out or they can be closed. But they can never fall down like this. Okay? So now let's try what happens actually. Say the observer is observing from here. So it comes as observer. Then this plane is removed. Here comes the object and there comes the reference plane on which I will be having the left hand side view given as P double dash, that is left hand side view. Whereas when you talk about this part, this is observer, object and the projection will be coming on this plane now like this. And what we have is PP double dash on the right hand side view. So we have obtained the two views and as we know that this point does not exist, only its representation is existing, so I will simply remove it from here. Now we have got only and only the projections left or the different views which are left out there. Now what to do? Simply I will open these planes outwards like this. Obviously I cannot close them because if I close them my front view and my side view will be overlapping. So I have to simply open them outwards. And once you open them outwards, see what happens. If say I am standing out here, if this is the VP and these are two PPs, if the left hand view is coming on this side, left hand side view, and the right hand is coming on this side, so if I simply open it out like this, what I see is left hand is going on my right hand side, whereas the right hand side view is going on my left hand side in the first quadrant. So once you open it, so when this is open, you will see this part out here and out here. So this will be, you will be having left hand side view and this will be your right hand side view. And by what degree will be opening it? Obviously the answer is 90 degrees because we are doing orthographic projections. So this is all about the opening of the planes and regarding the planes of your vertical plane, horizontal plane and the two profile planes. These planes can be very well fitted in the third quadrant also to get the views, and in that case I will be having, by using the same equation for the third quadrant, that is for third quadrant I will have it in this way. Observer, then comes the reference plane and then comes the object. Obviously they will be opening outwards, so I will have it out here like this and like this. So my left hand side view will come on my left hand side, whereas right hand side view will go on my right hand side. That is in the third quadrant, and this one is for the first quadrant. Obviously, we will be dealing only with the first quadrant throughout our discussion. So till now, we have seen how the views are being obtained on the totally imaginary and transparent planes, those were HP, VP and profile plane. And now let's see, because of this concept of orthographic, why we are able to see only two dimensions of a particular object. Let us consider a block. You can also say that this block is nothing but a bogie of some train and you are standing on a railway platform. Obviously, if you are standing out here and looking from here, then you would be able to see only and only this part. That is the length of the object and the height of the object. The length and the height of it. And if the projections are taken from here, then obviously they will be going like this. So here what I obtain is simply the length of it, that is this, and then we obtain only and only the height of it. Now if you start observing this object from the top, say from here, then in that case, that is the object out there. So obviously when you are standing out here, then you will be able to see the width of it and again the length of it. That is the length and the width. Again, this example can be understood in a very proper way. That is, say that train is standing on the platform and you are standing on the bridge. Now, if you are looking at the train, the bogie will be appearing only on the width-wise and the length-wise. You won't be able to see the windows and the doors of that particular train. So here I get two dimensions again, that is the width and the length out there. Going for the side view. Now, when we talk about the side view, obviously the observer is now here for the side view, and as we are doing everything in the first quadrant, it becomes observer, then it becomes object, and there comes its projections out here. And what I see is only the two dimensions, that is the height of it and the width of it. Now length is missing from here, so this is the width of it, whereas this is the height of that particular object. So in this manner, friends, if you see clearly, then in the front view, that is the front view, I am able to see only and only the length and the height of the object. Whereas in the top view, I am able to see only the length and the width of the object. Whereas in the side view, I am able to see only the height and the width of the object. So if you consider any two of these things, you can complete all the dimensions. Say if I want to go for the front view and the top view, what I have is length, I have height, and we have width. Whereas when you go for the top view and side view, you have length, you have width, and you have height. Where you talk about side view and the front view, you have height, you have width, and then you have length again. So by combining the two views, we can immediately get all the three dimensions of the object. And this will be helping us to when we go for the isometric drawing of the object. Now, once you have got this important concept from here, let me remain a mystery about your life. When did you come to know about this for the very first time? If you remember the very first drawing of your life, you have drawn a mountain like this. Now look here, as a child, you drew only the length of it and you gave only the height of it. There was no width given. So this is the first time you came to know about it, that okay, two-dimensional views are existing and now they are called as orthographic projections. Keeping all these concepts of HP, VP, vertical plane and horizontal plane, and getting the two-dimensional in orthographic view, we will be considering all other topics, and all these concepts will be readily used out there in different